Welcome to PV Online. Today we're going to look at the development of the periodic table. It started with a Russian scientist named Mendeleev who put the elements in order of increasing mass. And then he started noticing that there were some elements where they had similar behaviors, and so he put those in the same column. Later, Moseley decided to arrange the elements in order of increasing atomic number. Now remember that atomic number is the number of protons. It eventually led to the periodic law, which basically says that elements in the same column have similar properties. But ultimately it was Niels Bohr's introduction of the electron energy levels that changed the shape of the periodic table to what we have now. Okay, we've got an example of a periodic table. And in the periodic table, you can see that we can find out all kinds of information. You can find the atomic number, you can find the symbol, the average atomic mass. But there's definitely a reason that it's organized the way that it does, or the way that it is, and the fact that all of a sudden, why do we start a new row? Why does the first row start with just 2 elements, and the second row has 8, and so on? Okay, so we're going to take a look at that today because the structure of this, there's a reason behind it, and it makes the periodic table much more useful for us. Okay, so what I've drawn here is let's say I've got a hydrogen atom. A hydrogen atom, oops, let me get a pencil. So a hydrogen atom has 1 proton and 1 electron. And we know that the proton is going to be located in the center here, and that's going to be the nucleus. Well, now we have an electron, and the electron for a neutral hydrogen atom is going to be located in the first energy level, at the lowest energy level. So this electron is going to be zooming around. And the way Bohr looked at it is he thought that they had these certain energy levels. Now, later we'll find out that there are sub-levels, but for this course, we're just going to limit it to the levels. So this is going to be the hydrogen atom, and it's got 1 electron. I know it shouldn't look like that, but it's got 1 little electron that's going around the nucleus, and this would be the first energy level. Now, if we took a look at another element, suppose instead this time, we have, let's make it lithium. So lithium, has 3 protons and 3 electrons. All right, so in the middle, we know that we're going to have the nucleus, and in the nucleus, we're going to have the protons and neutrons. They're going to be densely packed there. And now we have 3 electrons. Now what happens with the electrons is there's a total of space for 2 electrons in the first energy level. So I'm going to have 2 electrons. That's the maximum that can go in the first energy level is 2. So let's say that we have these 2 electrons floating around like this, but I have a third electron. Well, that third electron is going to have to go out to the next energy level, which is the second energy level. So if we were to take a look at this, we would say that I've got 3 electrons. This would be my first energy level, and this would be my second energy level. I can have a maximum of 2 electrons in the first energy level. I can have a maximum of 8 electrons in the second energy level. Okay, but so let's take something that's a little bit bigger. Suppose that we have aluminum, and let's say that I have the isotope of aluminum 27. And what that means is this is the mass number, which hopefully you remember that means that's the sum of the protons and neutrons. Aluminum has an atomic number of 13. So if you look in the periodic table, let's scooch this up real quick. You can see right here, there's aluminum. It's got an atomic number of 13, and that tells me I have 13 protons. And if it's neutral, which is what we're working with right now, okay, we're going to have 13 protons. We'll have 13 electrons. And do you happen to remember how many neutrons you're going to have? Remember, the sum of the protons and the neutrons gives you your mass number. Well, those protons and neutrons are going to be in this nucleus in the center here. All right, this first ring is going to indicate the first energy level. The second ring is going to indicate the second energy level. And the third ring is going to indicate the third energy level. All right, so let's start filling in our electrons. Now, how many electrons can go in that first energy level? Remember, there's a maximum of 2. And so there's 2 electrons are going to go in here. So I've accounted for 2 of the electrons, but aluminum has 13. In the second energy level, you're permitted 8 electrons. 8 electrons can go in there. So I'm going to put 8 dots in here. So I've got my 8 dots. All right, so how many electrons have I accounted for? I've got the 2 in the first energy level. I have 8 in the second energy level. That took care of 10. So where do the remaining 3 electrons go? And they go in this third energy level. Let's just have 3 electrons zooming around here, like so. So the key to remember when you're doing these is there's a maximum number of electrons that can be in any given energy level. So in the first energy level, you're going to have 2 electrons. In the second energy level, there are 8 electrons. In the third energy level, it goes to 18. And in the fourth energy level, it goes to 32. Okay, so each successive energy level, you can have more electrons. The reason that you can do that is now you have more space. The rings keep getting farther and farther from the nucleus, so you've got the energy, or you've got the space for those electrons to be moving around.